Hi, this is Roger from Kanka Labs, today with a video about 4.5-digit multimeters. I've been thinking for some time about the title of this video. Should it be the development of 4.5-digit multimeters over the last 3 decades? Should it be every maker should have an EEV block 121GW multimeter? Or should it be what to watch out for or what to look out for when selecting a higher-end hobbyist's 4.5-digit multimeter? Now, all 3 topics will be discussed in this video, which may be split into 2 or 3 parts. So what we will cover in this video or video series will be, on the one side, the safety features of the multimeters, how they evolved during the last decades and what you have to look out for or watch out for, especially compared to my first multimeter, which was this one, which was so unsafe that it once exploded in my hands, and we will cover this topic quite in detail. And the other main topic is, of course, the features, especially the useful features, that once you have worked with them and once you know them, you will never want to miss them again. And I've now worked for half a year with the EV Block 121GW multimeter, and I can tell you this is the best multimeter with the most useful features that I know of. And there's a little Easter egg in the numbering or in the name of the 121GW. Just search in YouTube for 121GW or 1.21GW, and you will immediately find out why Dave Jones has given this multimeter the number 121GW. Just a little spoiler, it's a science fiction film from the 1980s where this 1.21GW plays a vital role. But before that, let's answer the question, why is it useful for a hobbyist to have a 4.5-digit instead of a 3.5-digit multimeter? And what are half digits? Now, when I started with electronics and got my first digital multimeter, that was the traditional 3.5 multimeter with the ICL 7107 chipset. And I was wondering even at that time, well, this thing had 2000 counts. Why was it called 3.5 digits? Because a digit is a factor of 10. If you get one more digit in resolution, you gain a factor of 10. So how could 2000 counts be 3.5 digit? And that is, of course, marketing bullshit, because there's only one way to find out the true resolution in digits of a multimeter, and that is because digits are a factor of 10. This is a logarithmic scale, so we just have to calculate the common logarithm of the number of counts. Now, for example, this one here has 20,000 counts. It has the successor to the ICL 7107 chipset. It's the ICL 7129 with 20,000 counts. And if we calculate the common logarithm of 20,000, we get 4.3 digits. So we are not 4.5 digit, but if we round it down a little bit, we have 4.3 digit. So, and these 2 multimeters have 50,000 counts. Now you are tempted now to think, well, 50,000, that's just in the middle between 10 and 100,000. So these could be true 4.5-digit multimeters. But let's take the common logarithm of 50,000 counts, and we get 4.7. So this is in fact more than 4.5 digits. It's 4.7, or round it down, 4 2/3, or round it up, 4 3/4 digits of resolution. So going from a 3.5-digit multimeter to a 4.5-digit multimeter has at least 3 distinct advantages. First of all, think that your measurement voltage, for example here with this multimeter, is slightly above 200 volts. Then you have to jump to the next higher range, or if you're having an auto-ranging multimeter like the two on the right side, it will automatically jump to the next higher range and you simply lose 1 digit of resolution. And that is not so much of a thing about the accuracy, because quite often it's not necessary to have a better accuracy than 1%. But if you're observing drift, then the additional digit that you get lets you observe much better a drifting voltage or current or resistance. And the third advantage is you get on the lowest range usually 1 digit of resolution down when stepping up. With a traditional 3.5 digit multimeter in the 200 millivolts range, your resolution would be 0.1 millivolts or 100 microvolts, while here you can see the resolution is improved to 0.01 millivolts or 10 microvolts. And with these two, you even go down to 1 microvolt, because this here, the X-Tech has a special function going up to 5.5 digits resolution when in the voltage mode. You can see here, if we go into the millivolts range and then change to 500,000 counts, then our resolution is 1 microvolts. And let's see what the EV block multimeter, you can see also the highest resolution is 1 microvolt. So with these two you gain 2 orders of magnitude in the lowest measurement range, and with this older one you get 1 digit of resolution more on the low side in the lowest measurement range. And the last advantage is, of course, when you get a little bit more serious in your hobby, you simply desire for better and higher resolution test and measurement equipment. So you usually will at some time step up from the, let's say, from the $50 multimeters to the $200 or euros multimeter, which all three of these multimeters did cost at their time. So it really makes sense, and it makes more fun to work with a higher resolution multimeter. Okay, let's start with an overview what you get when you buy or bought one of these multimeters and their outer appearance. And let's start with this Metex M4650B from the 1980s. What you got original is this little carrying case with the manual. So quite nice. Well, for the 200 Deutschmarks that this one did cost when it came out, which translates to around 200 euros or 200 US dollars nowadays, that was not always the case, that you got a little leather imitation carrying case. And the original test probes I don't have anymore, because they were of such a bad quality that I simply threw them away. Now you even today get, with the cheap multimeters, you get probes like these of extremely low quality, and you should immediately throw them in the garbage bin. Also these types, well, we have no feel or vision here, but from the feel you already can see they are useless. And in the, let's say, $50 range today, you get these kind or similar type of probes. They are already a bit advanced. They have these shrouded banana plugs so that you cannot touch accidentally your measured voltage or your device under test. You also can see the banana jacks. They are recessed, so you cannot touch them here even at the older multimeter, and in the more modern ones they even have a little plastic around them so that they are absolutely safe against touching. And what's quite nice about these, you can put the little plastic caps off, and then you can insert them directly into 4mm banana jacks. So that is quite a nice feature, and they are of medium quality. And you will always find in modern multimeters and probes something that's called a CAT rating. I will give you a link. These, for example, are CAT 3. This one does not have a CAT rating. I will give you a link about what the CAT rating means, and also about what to watch out for concerning safety features, and also about multimeter protection, etc., down in the video descriptions. So anyway, how has this evolved over time with the X-Tech multimeter, which in fact is a rebranded Bryman multimeter. These are the original probes that you got with them, and I hope you can see that these are gold plated. This is of course an important feature, because the non-plated probes, like this one here, which are at best nickel plated, if at all, you just get, especially in continuity testing, better contacts. And one of the most important features is how sharp they are. And the reason is when you're doing probing, you have to poke through the oxide layer that evolves in nearly every kind of component or solder junction. So the sharpness of the probes is extremely important. And you will see also that all modern probes have this little ring here, so that you cannot slip when, for example, when you have wet fingers, that you cannot slip over the, or not easily slip over this little ring here and accidentally touch the probe tip or touch any high voltage point in your device or circuit under test. So this is mandatory to get the CAT rating for the probes. And these are the probes for the EV block multimeter of very high quality. And you can see here you can pull also this little protection caps off. Usually you have them on, because when they are off, there's just the danger that you could accidentally touch more than one point, another component, a wire hanging around, etc. So it's always best, especially when probing IC pins, to have these little caps attached. And another thing you should watch out for is that the probe cables are extremely flexible, and this is only the case if you have them made out of silicone. There's an alternative if you want to upgrade your old multimeter. What in 99% of the time I'm working with this combination. These are separate silicone leads with standard banana plugs. Okay, they don't have the CAT rating because they have not this shrouding here in front, but that's not important for me. And you can clip on these ultra sharp probe tips. They are even sharper than the ones you get with the X-Tech or with the EV block multimeter, and there's nothing more important than having ultra sharp probe tips, so that you can poke through the oxide layer of your test points without applying any pressure. They will just by their sharp tips, even with the weight of their own, usually poke through the oxide layer, so that you can get a valid measurement result. And the combination of these not very cheap silicone cables and these attachable ultra sharp probe tips, that is just very versatile. And you can also, of course, exchange them for alligator or crocodile clips, or these, well, they are not mini grabbers, they are maxi grabbers with any kind of accessories you can plug into 4mm banana plugs. So this is the very versatile alternative that you will need anyhow, and that's why I made separate videos about the advantages of silicone cables and why every maker should have ultra sharp probe tips. And you cannot have enough different probe tips, grabbers, etc., because at one time or another you will always need them. Let's compare this to what you got in the 1960s or 70s with this analog multimeter. there you did not have 4 millimeter, but in fact 2 millimeter cables, and these are also of extremely low quality. Well, a nice feature is this mini alligator clips that you can clip on them, but today I would never work with such low quality probe cables and probe tips. And the advantage of these silicone cables over the traditional or cheap PVC cables is, first of all, they are extremely flappy, so that when you're probing something, or even if you use the grabbers, that your cable does not provide any extra force, but that your grabbers are just without the least possible force or torque are attached to your test points. Because sometimes your test points that you want to clip on are so delicate that if you apply any force, even your grabber will jump off or whatever. And the second is, silicone is much more resistant to heat, especially to the heat of your solder stations, that if you accidentally have your solder tip, your hot solder tip, touching the silicone, it will survive this without any problem, while the PVC leads, they disintegrate into hydrochloric acid. So although silicone leads are quite expensive, it's a once in a lifetime buy, because they will usually last forever, and once you've worked with silicone leads, you never want to work with PVC leads again. Another thing that has evolved over the time is the material of the case of your multimeter and your stand. Well, the stand became more or less a standard in the 1970s. You just should watch out for that when you're operating the multimeter, that it doesn't slide or fall off. Let's see what we get here. So these are, of course, all the multimeters you see here are all perfect in that. But another thing is that you can see these two more modern ones, they have a rubber holster that, if you want to, can take off just to protect it when it falls down, that it survives. So in fact, because this was my first expensive multimeter, I really took care that this never fell off the table, but once or twice it did, and it did survive in fact. But of course you have much better protection with this extra little rubber holster. And there's another thing you can't see that also has to do with protection of the multimeter and of yourself. In case of if you're accidentally probing a low impedance voltage or current source and you accidentally are measuring in the amps range, then of course hopefully the fuse of your multimeter will blow, but there might be some strange gases or steam coming out of your multimeter. And the modern multimeters, they have a double insulated case, quite often also with an additional rubber gasket. This one, I've made two videos where I took these two multimeters apart. You can see these are just two halves of plastic just clipped together, while here we have extra rubber seals and a double-walled case. So that is just in case you make accidentally a measurement where not only your fuse blows, but perhaps other parts of your multimeter could perhaps even evaporate, that you don't have to inhale any toxic gases or something like that. And that in case of a real, let's call it an explosion inside the multimeter, that there are no parts coming out of your multimeter. So modern multimeters are much better protected against these fault situations than the older ones, although I never had any problem with that. I sometimes blew the fuse inside, but that was no problem. So speaking of fuses and input protection, well, this multimeter here has a single fuse only in the normal amps range, going up to 2 amps. And it has a simple 5 by 20 millimeter glass fuse. And these glass fuses are no longer used in modern multimeters simply because they can explode. Just imagine that you have accidentally in the amps range a very high current of, let's say you're probing accidentally the mains voltage, a mains outlet, and this poor little 2 amps fuse can get now a surge current of perhaps 100 amps, and then the little wire inside will evaporate, and the pressure of the evaporated gas will just make this little thing explode. And that is not a nice thing. I even had an incident when repairing a stereo amplifier and I accidentally shorted the power supply lines. Then one of these glass fuses exploded and the glass nearly hit my eye, so I was just quite lucky. And another thing you can see is here that the 20 amps range is unfused, while in modern multimeters the amps range is protected by these so-called HRC fuses. You can see they have a ceramic body and are much safer, especially against the case of exploding. They even have some material inside to extinguish any flames or something like that that could evolve in a case of a heavy failure. And I've made a separate video about why these HRC fuses are much better than your traditional little glass case fuses. So concerning amps measurements and failure modes there is one feature that I think is indispensable today, and I'll show you what has happened a lot of times to me when working with old style multimeters like this one. You're just measuring something in the amps range, and you're in the highest range, here it's 20 amps, and now you're changing to measuring volts, and you forget to reinsert your positive plug into the volts and ohms or general socket, and you leave it in the amps socket. What then happens is you basically have a short, because there's only a traditionally 10 milliohms shunt resistor here between the common and the 20 amps input. And that means if you're thinking you're measuring volts, but in fact you're shorting out your circuit between wherever you're probing, the positive and negative probe. And what happens is, think of you're probing a very expensive device, then it could be destroyed by just shorting it out. So with these traditional older multimeters, you always have to watch out, replug your test lead into the common socket. And let's simulate what happens here with the X-Tech multimeter. I have plugged it in the 10 amps range, which here is fused, in contrast here to the 20 amps range, which is non-fused. And now we're changing back to anything else but amps mode, and you can see it starts to beep and it shows input error. And that has saved me not only a lot of fuses, but it has saved me some devices that I probe, because you cannot accidentally now short out your device or your circuit. The other way around is no problem. If you're measuring volts and have your probes correctly plugged in the right socket, and now you're changing into the amps mode, it will not display a fault error. The only thing that happens is you don't measure any current because it's not plugged in the right input terminal. So no problem for that kind of faulty connection. And the EV block multimeter has the same feature. When we're plugging the lead into the amps socket and we're not in amps mode, then it starts simply to beep. It even can differentiate between the higher amps and the milliamps and microamps mode. So that's how it should be. So, and the other fault mode is of course over voltage. And the protection for that should be for all ranges, not only when you're accidentally probing something in the thousands of volts region and you're And not only that your DC and AC volts range is then protected by any kind of means, but also if you have accidentally a voltage present and you're in the ohms mode or here in the frequency mode, etc. So there should be a high voltage protection. That is here with a single spark gap, while in more modern multimeters you find a whole range of protective elements like these blue varistors, these little green MOFs, metal oxide varistors. Here we have another varistor. You usually also have some diodes. Well, here are also some 1N4001 antiparallel diodes in the common input. But also there I will give you a link about multimeter protection, and you can also watch the teardowns of especially the X-Tech where I explain all the components that I used there for input protection. So with these two modern multimeters you can be 99.9% sure that you are safe, your multimeter is safe because it costs a little bit of money, and your device under tests is as safe as possible. So that's how it should be, that any component or human involved is just safe against human failure or instrument failure. So let's compare this with the protection or non-protection you had in this 70s style analog multimeter. First of all, you can see you don't have separate volts, ohms and amps input, just in contrast to the modern multimeters where the amps inputs are always on separate jacks. So that means that by changing the range accidentally from volts to amps, and you have connected this still to a low impedance source, then you have to pray that your multimeter or your circuit survive. And if we take a look inside, there is not a single protection element, no fuse, no MOF, no varistor, nothing. So what will happen is at best your moving coil instrument will survive because this is protected by two diodes. But my first one did not survive. There was one or two of these carbon film resistors that exploded when I was accidentally probing mains voltage and changed accidentally into the amps range. So this is not my original multimeter. I bought this on eBay just for demonstration how it was done back in the days. And you can see for today's standard, this thing is completely unsafe, and there's simply absolutely no reason to use any old analog multimeters in the modern world where safety is a thing of your personal concern. So that shall be it for today, for a broad overview and the safety features to watch out for. Next video will be about the features, how they evolved over the decades. And there you really will find out how superior the EV block multimeter is to anything else that I know is on the market, especially concerning the price. There's something you should not tell Dave Jones, who was involved in the development of this multimeter. I would have even bought it for 50% more than the price. I think they're around $200 you pay for this multimeter. It's an absolute bargain price. So thanks for watching. If you liked it, please give it a big thumbs up. You can support me on Patreon. And thanks for watching. Until next time, bye from Roger, bye from Kanka Labs.